Additional equations and formulas. Let's consider the following equation. Now, technically, this is a quadratic equation, and one way to solve it would just be to multiply everything out. So x plus 3 squared means x plus 3 times x plus 3. And then we have minus 2 times x and minus 2 times 3, so that's negative 2x minus 6. Minus 8 equals 0. And then we can multiply this out. That's going to give us x squared plus 6x plus 9. And then minus 2x, and minus 6 minus 8 is minus 14. And so we have x squared plus 6x minus 2x is plus 4x. And 9 take away 14 is minus 5. And now I can factor x plus 5, x minus 1 equals 0. And setting each of these factors equal to 0 gives us negative 5 and positive 1. Now, there's absolutely nothing wrong with solving the problem this way. This is just what I call brute force, right? We're just solving it as it appears. But there is another way to approach these kinds of equations. Let's consider making a substitution. What if I said, let the expression x plus 3 be equal to some new variable? Let's call it u. Notice I'm doing this because x plus 3 appears twice in this equation. And if I replace x plus 3 with u, that equation becomes u squared minus 2u minus 8 equals 0. And this we know we can solve by factoring. And the factoring here is pretty simple. And then we can set each of these factors equal to 0. And of course, we get our two answers, u equals 4 and u equals negative 2. And there's a lot less complexity involved when we do it this way. But we're not quite done, right? Because we're solving for x in the beginning, and u is equal to x plus 3. So I have to put x plus 3 back in for u. So x plus 3 is equal to 4, and also here x plus 3 is equal to negative 2. And now by subtracting 3 from both sides, I get one solution is 1, and the other solution is negative 5. Now notice we're getting the same solutions, but a different method. And this is called, solving by substitution. And what we're doing is we're recognizing that this original equation is sort of like a quadratic equation in that you have a second degree, and you have a first degree, and you have a constant term. And by making a simple substitution, you actually get a quadratic equation that, in this case, is fairly easy to solve. Let's take a look at some other examples. Now, in our next example, we have a third-degree polynomial equation, and we did an example of a third-degree equation in the previous section. Most important, you want it to be equal to 0, which it is. And then let's recognize that we need to factor the left-hand side. So let's think of that as 3t quantity cubed minus 2 quantity cubed. This is a difference of 2 cubes, and it factors. You might need to review how to factor a difference of 2 cubes, but this is how that works. And then now we just need to set each one of these factors equal to 0. And so the first factor is going to give us t equals 2/3. And the second factor, this requires the quadratic formula to solve. So t is going to be negative 6 plus or minus the square root of 6 squared, which is 36, minus 4 times 9 times 4, all divided by 2 times 9. And now we'll just simplify. Negative 6 plus or minus the square root of 36 minus 144 divided by 18. And 36 minus 144 is going to be, that's going to be the square root of negative 108. So notice we have the square root of a negative. So this negative needs to come out, and when it comes out, it's going to be an I. So negative 6 plus or minus I times the square root of 108 divided by 18. And the square root of 108, you can actually simplify that by thinking of 108 as 36 times 3, and that becomes 6 radical 3. So we have negative 6 plus or minus I times 6 radical 3, which is 6I radical 3, divided by 18. Now we can reduce. 6 goes into 6 one time, 6 goes into 18 three times, and 6 goes into 6 here one time. And so we have negative 1 plus or minus I radical 3 divided by 3, which if we write this as two separate answers, we have negative 1/3 plus or minus radical 3 over 3 times I, and negative 1/3, that should be plus, sorry, and negative 1/3 minus radical 3 over 3 times I. And so that equation has two solutions, and then don't forget we also have the solution up here, and so in total, we have 3 solutions. Now in our next example, we have a 4th degree equation. First thing I'm going to do here is recognize that when we're solving polynomial equations, we want to make sure that it's equal to 0. So I'm going to subtract 2 from both sides. That gives us 4x to the 4th plus 7x squared minus 2 is equal to 0. And this is kind of like the first problem. So this is not a quadratic, but it's very similar to a quadratic. Think about it like this. 4x to the 4th is 4 and then x squared quantity squared. And then we have 7 times x squared and then minus 2. And to solve this, I could make a simple substitution by simply letting u be equal to x squared. And this becomes 4u squared plus 7 times u minus 2 is equal to 0. And from there, you could try factoring. I do believe factoring works. We could use a magic x. I'll leave that to you. I am just going to put down the correct factorization. And now when we set each one of these factors equal to 0, the first equation gives us u equals 1/4, and the second equation gives us u equals negative 2. But now let's remember, u was x squared. So in the first equation, we have x squared equals 1/4, and in the second equation, x squared equals negative 2. So in the first equation, if I just take the square root of both sides, we get x is equal to plus or minus 1/2. So those are two solutions. And in the second equation, when we take the square root of both sides, we get x equals plus or minus, and then that becomes I radical 2. So there are 4 solutions here: 1/2, negative 1/2, I radical 2, and negative I radical 2. And so notice that we get 4 solutions when we have a 4th degree equation. And that in general, that's not a coincidence. Now our next example is an example of a rational equation. So this is when we have fractions involved. And this particular equation is kind of special. If I have two fractions are equal to each other, we know that this means that the cross products are equal. So if I multiply a times d, that must be equal to b times c. So we can use this property to help us solve this equation. So I'm going to multiply 6 times 8, which of course is 48, and that must be equal to 3 times a minus 4, which I'm just going to write down 3 times a minus 4. Multiplying this out, we have 3a minus 12 on the right-hand side. And then from there, it's pretty straightforward. If we add 12 to both sides, we get 60 equals 3a. And then finally, dividing by 3, a is equal to 20. Now, one final thing to consider in a problem like this, anytime you have a variable in the denominator of a fraction, you have to think, if we were to plug that answer in for that variable, would we be dividing by 0? And the answer here is no, right? If we plug 20 in there, we get 20 minus 4, which is 16, and there's nothing wrong with having 16 in the denominator. But sometimes the answer that you get here will make the denominator 0, and if that happens, we have to exclude that answer. Now, our next example is a little bit more complicated. We have x over x minus 2 plus 2/3 is equal to 2 divided by x minus 2. And notice that I can't cross multiply like in the previous example because we have two fractions on the left-hand side of the equation. So in this problem, we have to go back to multiplying both sides by the least common denominator. And the least common denominator is going to be x minus 2, but also multiplied by 3. So I'm going to take this equation, and I'm going to multiply by 3 and x minus 2 on both sides of the equation. Now on the right-hand side over here, the x minus 2 simply cancels out, and we get 6, right? Because that's all that's left, 2 times 3 there. But on the left-hand side, it's a little bit more complicated. So when we multiply here, we're going to have 3 times x minus 2 multiplied by x over x minus 2. But then we also have to multiply here. And so that is 3 times x minus 2 multiplied by 2/3. And so here we get cancellation, and what we have left is 3x. Plus, here we also get cancellation. 3 cancels out, and we've got 2 times x minus 2. And again, on the right-hand side, we just have 6. And from here, it's pretty straightforward. Multiply out the parentheses. Combine like terms, we have 5x. If I add 4 to both sides, we get 10. And so dividing by 5, we end up getting x equals 2. But if you go back to the original problem, x can't be 2, right? I mean, just look at the denominator here. If you plug 2 in here, you get 2 minus 2 is 0, right? So let me just show you this one time. If I plug in x equals 2, we're going to get 2 divided by 2 minus 2 plus 2/3 is equal to 2 divided by 2 minus 2. And this is 2 divided by 0 plus 2/3 is equal to 2 divided by 0. And we can't do this, okay? So it's not even, you don't even have to look at what's on both sides. You can't divide by 0. So this answer is no good. But that was the only answer that we had, and so this problem has no solution. So here's another example. Again, very similar to the previous two examples. We have 1 over x plus 2 minus 1 over x is equal to 1/3. Let's identify that the least common denominator is 3 times x plus 2. And I'm going to multiply both sides by that least common denominator. So when I multiply here, we're going to have 3x plus 2 multiplied by that, and then 3x plus 2 on the other side. Okay, there we go. And now we're going to cancel. So x plus 2 cancels out, and we have 3x times 1, which is 3x, minus. Then we have the x cancels out here, and we have 3 times x plus 2 times 1, so that's going to be minus 3 times x plus 2 equals, on the other side, the 3's cancel out, and we have x times x plus 2. All right, so now the denominators are gone. Now we just have to focus in and solve the remaining equations. So we've got 3x minus 3 times x, and then minus 3 times 2, so that's minus 6, equals, here we have x squared plus 2x. 3x minus 3x cancels. We have negative 6 equals x squared plus 2x. And then if we add 6 to both sides, we end up getting 0 equals x squared plus 2x plus 6. So now this is the equation that we need to solve. This does not factor. So we're going to use the quadratic formula. X will be negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 6, all divided by 2 times 1. This is negative 2 plus or minus the square root of 4 take away 24 divided by 2, which is negative 2 plus or minus the square root of negative 20 divided by 2. Now, once again, please don't cancel these. We need to simplify this first. So the negative, we can pull that out as an I. So we have negative 2 plus or minus I radical 20. divided by 2. And then the square root of 20 is the square root of 4 times the square root of 5, which is 2 radical 5. So this is negative 2 plus or minus 2 radical 5 divided by 2. And there is an I in there. Whoops, forgot my I. There we go. And now the 2 cancels out with all those. But don't forget here, you do have a 1 left over. So this is equal to negative 1 plus or minus I times the square root of 5. Now that's two answers. That's negative 1 plus I radical 5. And that's negative 1 minus I radical 5. And neither one of those answers is going to make the denominator 0, right? Think about it. What would make the denominator 0? Negative 2 would make that 0, and 0 would make that one 0. So these are the only answers that would not be okay. But we did not get those answers, right? We got these answers, so we are good. Next example, another rational equation. 3 plus 1 divided by x is equal to 10 divided by x squared. Same technique. Least common denominator is x squared. So now let's multiply both sides by x squared. On the left-hand side, we're going to get x squared times 3, which is 3x squared, plus x squared times 1 over x. So that x is going to cancel one of the x squareds. And on the right-hand side, the x squareds completely cancel out. And we just get 10. This, of course, is 3x squared plus x minus 10 is equal to 0. And from here, we could try factoring. We could use quadratic formula. It's totally up to you. I think this one might factor. So let's see. If I put a 2 here and a 5 here, a positive and a negative, yeah, I think that works, doesn't it? Now, you might be wondering how I'm factoring that. It's just because I have a lot of experience factoring, and once you gain that experience, you can do a lot of this stuff in your head. Remember, you can always rely on the magic x, which is going to be multiplying 3 times negative 10, which is negative 30. You have a 1 here in the middle, and the numbers that you can use to multiply to get 30 and add to get 1 are going to be 6 and negative 5. So when you factor it, it's going to be x plus 6, x minus 5. And then don't forget, you have to divide by 3, because this is the magic x magic, right? This is what makes it magical. And then the last step is we're going to move this 3 up here, and that gives us 3x minus 5. And you'll notice that that's exactly the same as what I have over here. So once I get that factored, now I'm just going to set each one of these factors equal to 0. Here we get x equals 5/3, and here we get x equals negative 2. And then just make sure you check to make sure that your answer does not make the denominator 0. And we are good, because the only answer here that would have been bad would be x equals 0, right? X cannot be 0. But again, we didn't get 0, did we? We got these two answers, and so we are good. Now, slightly different type of problem. So we still have a rational equation. We have y minus 4 divided by x minus 5 is equal to 3. But this is not really an equation per se. This is a formula. Remember, a formula is an equation that has more than one variable, which is exactly what this has. So what we're doing here is we're solving this equation or this formula for y. So we want to get that thing right there by itself. So now to do this, I'm just going to make the right-hand side a fraction, and I'm going to go ahead and cross multiply. So y minus 4 times 1, right? It's just y minus 4. And then here we have x minus 5 times 3. That's going to be 3 times x minus 5. And so we have y minus 4 equals 3x. Whoops, I put 15, didn't I? Getting ahead of myself. So we have 3 times x minus 5, and then when you distribute there, you get minus 15. And then I'm just going to add 4 to both sides, and that gives us y equals 3x minus 11. And so we have solved for y. Next example, pretty much the same thing. So we have x is equal to y minus 4 over y minus 2. Once again, we are solving for y. So let's put a 1 here. Let's go ahead and cross multiply. So we have x times y minus 2 is equal to 1 times y minus 4, which is just y minus 4. Now, the difference in this equation is, notice that you have a y on both sides. Right, so that makes it a little bit more complicated. So let's multiply out the parentheses on the left side. And if you're trying to solve for y, you need to get each of these y's on the same side of the equation and everything else on the other side of the equation. So what I'm going to do here is subtract y from both sides, and then I'm going to add 2x to both sides. Okay, let's see what this does. So subtracting y is going to get rid of this. Adding 2x is going to get rid of that. On the left-hand side, we have xy minus y. Right-hand side, we have negative 4 plus 2x, which I can write as 2x minus 4. Now, for solving for y, the important step here is that you have two occurrences of y. You're going to factor that out. And when you factor that out, you get a single occurrence of y. And then we can just divide both sides by x minus 1. And doing that gives us y equals 2x minus 4 over x minus 1. And we have solved for y. Here's an example of a rational expression or a rational equation. Francine plans a 60-mile training run on her cycle plane. The time required for the training run in terms of the wind speed x is given by this formula. So the time t is equal to 60 divided by 15 minus x, where x is her speed. If it takes Francine 9 hours to cover 60 miles, what is the speed of the wind? Okay, so they're telling you that t equals 9. So we're going to plug 9 in there. That gives us 9 equals 60 divided by 15 minus x. Now, don't be confused when they say, to cover 60 miles. That's already accounted for in the formula, right? That's why you have a 60 up on top. So we don't have to do anything with that. So now we're just going to cross multiply. So we have 9 times 15 minus x is equal to 60 times 1, which is 60. 9 times 15 is 135. Minus 9 times x is negative 9x. So here I am just multiplying this out. And then I can subtract 135 from both sides, and that gives us negative 9x is equal to 60 minus 135, which is going to be negative 70. And then dividing both sides by 9, let me go ahead and show that step. Actually, dividing by negative 9 is going to give us x is equal to 70 divided by 9, right? Because we can cancel the negatives there. And 70 divided by 9, this is the speed of the wind, right? So probably we want to give this answer not as an improper fraction. 9 goes into 70 how many times? 7 times, right? 7 times 9 is 63 with 7 left over. So it's 7 and 7/9. And if you plug this into a calculator, you should get about 7.8 miles per hour. Okay, that's the speed of the wind. Another type of equation that we run across is an equation that involves a square root. So here we have the square root of 3x plus 4 is equal to 5. How should we solve a square root? Well, you want to get rid of the square root, okay? So let's remember that if we have a square root, such as the square root of x, if we square that, this just becomes x. So what we're going to do here is we're going to square both sides of the equation. And the reason we're doing this is because on the left-hand side, we just get 3x plus 4. On the right-hand side, we get 25. And see, now we know how to solve this equation. So once you get rid of the radical, that's pretty much all there is to it. So here we're going to have x is equal to 7. Now, you must check, okay? You must check your answer. Because sometimes you can do everything right and your answer still doesn't work. And I'll talk about why that is in just a minute. But let's check our answer, x equals 7. We're going to plug it back into the original equation. That's going to give us the square root of 3 times 7 plus 4 is equal to 5. That's the square root of 21 plus 4, which is 25. And is that equal to 5? And the answer is yes, it is. 5 equals 5, right? So it checks. Now, the reason you can sometimes get bad answers is because you might have a bad equation to begin with. So, for example, if I have 4 is equal to 4 and I square both sides, we're fine, right? Because that's just going to mean 16 equals 16. But if I have 3 equals negative 3, which of course is not true, if I square both sides, we get 9 and 9. And so suddenly it becomes true. So anytime you square both sides, you might be okay, or you might not be okay. And you just don't know. You don't know ahead of time. So anytime you square both sides of an equation to solve it, you have to check your answers. In the next example here, it's pretty much the same thing. We have the square root of 5x minus 1 plus 3 is equal to 7. I'm going to subtract 3 from both sides. This is going to isolate the radical. So we want to get that radical all by itself. And then now I'm going to square both sides. And so the left-hand side becomes 5x minus 1. The right-hand side becomes 16. Let's add 1 to both sides. We get 5x is equal to 17. And then dividing by 5, we get x is equal to 17 over 5. And I'll skip the checking part. This answer does indeed work. Okay, same thing in this problem. So we have t plus 5 is equal to the square root of t plus 7. Once again, we want to get rid of the radical, and we do that by squaring. But now notice that you have a variable on both sides. That's going to make things a little bit more involved. So we'll go ahead and square both sides. And on the right-hand side, we do indeed just get t plus 7. But on the left-hand side, we get t plus 5 times t plus 5. And if you multiply that out, that's t squared plus 10t plus 25. Okay, so now we have a quadratic equation. And to solve this, we need to set it equal to 0. And that's going to give us t squared plus 9t plus 18 is equal to 0. And for this, we can factor t plus 3, t plus 6 equals 0. And finally, setting each factor equal to 0, we end up getting t equals negative 3 and negative 6. And then don't forget, you have to check. So if t equals negative 3, we're going to plug that in here. Negative 3 plus 5 equals negative 3 plus 7 under the square root. This says 2 equals the square root of 4. Yes, this is true. So t equals negative 3 is good. If t equals negative 6, we get negative 6 plus 5 is equal to the square root of negative 6 plus 7. This says negative 1 equals the square root of 1, or negative 1 equals 1. And of course, this is not true. So the only answer here is t equals negative 3. And the final example, yet again, another radical equation, but this time you have 2 square roots. When you have 2 square roots, normally you won't be able to isolate both of them at the same time. So what you do is just isolate one of them, right? So this one's all by itself, so we're good. So we'll go ahead and square both sides. The right-hand side becomes x minus 3, but then, the left-hand side becomes x minus 3. But then the right-hand side becomes the square root of x minus 3 times the square root of x minus 3, and we have to FOIL this. So multiplying this out, radical x times radical x is x. Radical x times negative 3 is negative 3 radical x. Negative 3 times radical x again, and then negative 3 times negative 3 is positive 9. Now I'm going to subtract x from both sides. I can cancel those. I'm going to add 3 to both sides. That will cancel those. And that gives us 0 equals negative 6 radical x plus 12. So notice after squaring both sides, we still have a radical. So what I'm going to do is I'm going to add this over to the other side, which gives us 6 radical x equals 12. Then I could divide by 6, and that gives us radical x equals 2. And then I need to square both sides again. And this is going to give us x is equal to 4. And then you have to check that answer, and I will tell you that this answer checks out. And that concludes this video lesson.